The rule for multiplying fractions is a simple one. You multiply the numerators and then you multiply the denominators. All right, so if you see over here, we have these two fractions multiplying each other. You multiply the numerators over the denominators. Okay, and then you get 504 over 1260. Now, here's where the student is usually having issues, is when they're supposed to simplify the answer to its simplest form. Okay, this is not an easy fraction to simplify. Even if you used a factor tree, that could take a while. Okay, so what is recommended is you actually simplify before doing the multiplication. Right? That would make sense because by simplifying beforehand, you make the fractions as small as possible, and then when you multiply, you won't get such a big number. Right? It's possible that you still need to simplify after, but it wouldn't take very much to get it to its simplest form. Okay, so we actually have a couple methods they can do. We're going to go over 3 different methods. All right, the first one is going to be the fastest, but it's also going to be the hardest, or it's going to require the most mental math. All right, so you'll see over here, I'm going to go ahead and apply the rule. All right, multiply the numerators and then multiply the denominators. Okay, now before actually doing that, I'm going to go ahead and simplify the fraction. I'm going to see which of these numbers have common factors that I can reduce the factor by. All right, now this is where the mental math comes into play. As I find a factor and reduce it by that factor, I'm going to change the number to its reduced form. So for example, 35 and 21, they both share the factor of 7. So if I divide 35 by 7, I get 5. 21 divided by 7, I get 3. Okay? And then now I can go ahead and see if 3 in another number has a common factor. Now you just have to be careful that you cannot go side to side. Right? You can only start reducing from top to bottom. Okay, so 3 and 36 can both be divided by 3. So 3 divided by 3 is 1, 36 divided by 3 is 12. And then 24 and 12 can be reduced by a factor of 12. All right, and then I'm left with 2 times 1 over 5 times 1, and that is simply 2 over 5. Right, as you can see, that is going to be a lot easier than 504 over 1260. Okay, in this case, it's actually already in reduced form. Okay, but like I said, this will require the student to do quite a bit of mental math, right? So if they were not able to follow along completely, I suggest they use method 2. Okay, we're gonna do the same thing. Apply the rule. Right, but here we're simply just going, same concept as method 1, but we're going to actually write out the factors. Okay, and what I'm going to do is I'm going to reduce each number to 2 factors. Which 2 factors is up to you. Some you're restricted to only 2, some you have multiple options. It doesn't really matter, just pick one. So 24, I can break that up into 4 times 6, and then 21 is 3 times 7. Okay, 35 can be broken into 5 times 7, and then 36 broken into 6 times 6. Okay, now that I've done that, I can go ahead and see which of these factors I can cancel out. Okay, so 6 can cancel out with 6, 7 with 7. All right, now I'm not done. Right now I can continue to break the numbers down until it's in its prime form, or I can go ahead and multiply. I'm going to go ahead and keep reducing. So 4 can be further reduced to 2 times 2. I still have the times 3 there. And then 5 stays 5, but then 6 can be reduced to 2 times 3. All right, and now I have more numbers I can cancel out, and then I'm left with 2 over 5, right? Which is what we got before, right? So as you can see, the two methods, this one takes a little longer, right? But there's not as much mental math involved, okay? Now this is the method that I like to use, and it's actually not in the textbook, so hopefully that works for the student. If not, then the last method is the factor tree method, okay? And this is the one that is used in the textbook, and this is the, I would say the simplest, but it may take the longest, okay? So I already did the factor tree. Basically, I am breaking each number down to its prime factor form. All right. So as I write the rule, 24 times 21, 35 times 36, I'm going to replace each number with its prime factor form. So 24 is 2 times 2 times 2 times 3, and then 21 is 3 times 7. Oops, 3 times 7, there you go. Okay, 35 is 5 times 7, and then 36 is 2 times 3 times 2 times 3. Alright, now just like method 2, I can start canceling numbers out as I have common ones. 3, 3, 7, 7, and then I'm left with 2 and 5, 2 over 5. Okay, so this method doesn't take that much longer, but just a little longer just because you need to do the factor tree for each individual number. Right, and if you compare it with the second method, it really isn't too different. Okay, the second method saves time and that you don't need to use the factor tree, right? But you're basically doing the same thing. You are breaking the number down into 2 additional factors, right? And sometimes if you get lucky, that's all you need, all the numbers cancel out. If not, you may have to break it out again like we did over here. Very rarely you need to break it out the 3rd time, but even if you do, it still should be a little faster than method 3. Okay, now method 1 is still the fastest, but like I said, that's going to require more mental math capability, which not every student can do. I do not suggest using that unless the student is comfortable doing some math in their head. Okay, so method 2 is what I would suggest doing, and if they're still not comfortable doing that or they're still making mistakes, I would go with method 3. All right, now just another example. Right, so I got example 2, and I'm actually going to throw in a mixed number. Okay. Alright, so what happens if we have a mixed number? And if you look at our rule, it does not say anything about mixed numbers, except that we can change every mixed number into either a proper or improper fraction. Okay, by doing so, it would conform to the A over B times C over D format. Okay, so we just need to do a little extra math to the side. 2 and 3 over 16 is really the same thing as 35 over 16. Alright, now I did some mental math there. To work it out, I multiply 2 times 16, and then I add the numerator. That's how I get the 35. Okay, if you remember, 2 is the same thing as 32 over 16, and you're adding that to 3 over 16. That's how I get the 35 over 16. Okay, so then this is actually 35 over 16 times 8 over 20. Okay, now we could just go ahead and multiply out like over here, but then we're probably going to get a big number, so we suggest simplifying first before actually multiplying. Alright, so 35 times A, 16 times 20. I'm going to go ahead and use method 2, right, where I'm simply going to break each number down once. All right, so 35, I have no choice, it's just 5 times 7. 8, kind of same thing, I have to do 2 times 4. 16, I have a choice, right, between 2 times 8 or 4 times 4. I usually just like to go with the middle one. And then 20, same thing, got choices, but I'm going to go with 4 times 5. Okay, and after I do that, I can go ahead and cancel out common factors. Okay, now as long as I still have numbers that are not in prime factor form, I need to keep on going just to make sure that every number is accounted for. Okay, 7 and 2 stays at 7 and 2 because they are already prime. All right, so if you see, by doing that, I can cancel out additional 2. And now my answer is simply 7 over 2 times 2 times 2, which is 8. All right. So again, I recommend using method 2, but if not, they can just go ahead and use a factor tree and they'll get a longer list of numbers here, but for sure they know that once they cancel everything out, they have it reduced to the simplest form because you already went through all the possible factors. Now the rule for dividing fraction is over here, and as you can see, we don't actually divide. What we do is we change it to a multiplication problem by multiplying the reciprocal. Alright, and to get the reciprocal of a fraction, you simply flip the numerator and the denominator. So you see over here, C over D becomes D over C. And instead of dividing, we are multiplying. Okay, and we know once we do that, we can get the answer because we just did multiplying earlier. Okay, that's simply, this is the same thing as this over here. Okay, so this equals to 17 times 56, 32 times 34. Alright, and like we mentioned earlier, we're going to go ahead and simplify before multiplying because that would make the simplification process a lot easier. Alright, so I'm going to go ahead and this time I'll use the factor tree method where I'm going to factor out all the numbers. Our 17 is already prime, I can't do anything about that. 56, I can split it into 7 and 8, 2, 4, 2, 2. Alright, 32 can be split into 4, 8, 2, 2, 2, 4, 2, 2. And then 34 can be split into 2 and 17. Alright, so I'm going to go ahead and rewrite this as 17 times 56, but instead of 56, I'm going to use its prime factor form, which is 7 times 2 times 2 times 2. Alright, all of that is over 32, which can be rewritten as 2 times 2 times 2 times 2 times 2. Alright, and then 34 can be written as 2 times 17. Alright, and now I simply find common factors and cancel them out. Alright, I'm left with 7 for the numerator, and then 2 times 2 times 2 for the denominator, which is 8. Alright, and that's my answer. Okay, if I want to use method 2, which would be a little faster, right, that means I simply break down each number once, right? So 7 times 8 is 56, 4 times 8 is 32, and then 2 times 17 is the only option I have for 34. Okay, and from there I can go ahead and cancel anything I have in common. Okay, and I still have one non-prime number, which is 4, so I need to go ahead and break that down just to make sure that everything is accounted for. And it looks like I cannot cancel out any more factors, so I end up with 7 over 8. Okay, so I just did method 3 and method 2. I'm not going to do method 1. That's where you just go ahead and cancel numbers out, reduce it on the fly. Okay, but that requires quite a bit of mental math there. Okay, but as you can see, we started this problem out as a division problem, but we did pretty much no division. We simply changed it to a multiplication problem and then worked from there. Right, so it's very similar to when we were adding and subtracting negative numbers. Right, we never really learned how to subtract negative numbers. We simply learned how to change a subtraction problem into an addition problem, and then we added the numbers instead. All right, and same as earlier, if there was a mixed number involved, you simply convert it to improper form, and then you can go ahead and use the rule. Now here's why the rule works the way it works, where you can simply multiply by the reciprocal and get the same thing. Alright, so I'm going to show that by using the stacking method. Alright, so what I mean by that is I'm going to rewrite this problem by stacking the fractions on top of each other. Alright, now this is true because the division sign is basically a fraction bar. Alright, 17 over 32 really is 17 divided by 32. Okay, so by writing it like this, that gives us a different dynamic there. Okay, we can go ahead and utilize what we know about reciprocals and how denominators work. Anytime the denominator is 1, whatever the numerator is, that is the number. So for example, 27 over 1 really is just 27, or 17 times 6 over 1 is really just 17 times 6. Okay, so basically if we can somehow convert the denominator into 1, whatever the numerator is, that's going to be the number. Okay, and we can do that by multiplying the denominator by its reciprocal, right? Because we know that's, by definition, reciprocals, if they multiply by each other, you get 1. Okay, 34 times 56 divided by 56 times 34, and it's going to be 1. And we just need to make sure that we also multiply the numerator by the same fraction. That way we're not actually changing the number, because this whole thing right here really just equals to 1. And if we multiply any number by 1, we don't actually change the number. Okay, so we really don't even need to work this out because we know that this is just going to equal to 1. Alright, and then on the top we have 17 over 32 times 56 over 34. Alright, and then that is just 17 times 56, 32 times 34, and really we don't need to write over 1 because whatever the numerator is, that's the new number. And if you can see, that is simply applying the rule. We have 17 over 32 times 56 over 34, which is 34 over 56 flipped, or in other words, the reciprocal. Right, and that is the rule that was mentioned earlier, where we simply multiply by the reciprocal. Okay, except that in this case we didn't use the rule, we simply use what we know about fractions and utilize, multiplying by 1 or a different form of 1 to get the same result. So if you can memorize the rule, obviously you can go straight from here to here. You'll save a lot of time. But in the event that you forget the rule, you can still get to this step by doing a little bit of math. Here are some practice questions you can do. Alright, so you can go and pause the video so you can copy them down. Alright, and I'm going to show the solution in a second. And here are the solutions. or number 4, the answer actually goes up to here since I ran out of room over here. Alright, so pretty much for all of them, I used method 2, where I went ahead and broke each number down once, went ahead and canceled out any common factors, and then broke it out again if needed. Okay? As long as there are still non-prime numbers left, you can always break it out, and it's always good to do it to make sure that every factor is accounted for.